In this problem, we are asked to either write an NPAT formula or a y equals mx plus b formula, and we're also asked to create a graph. So when I look at the change values, and change we recall would be y2 minus y1, I see that they are not constant, which means it is not linear. Now, I was only given two options for the equation to write, so it must be exponential, but I'm going to cross off the linear formula here. I'm not doing that. And I look at my y ratios. I see that they are constant, and that does mean exponential. So I want to write an NPAT formula. I remember in the NPAT formula, the P is the start. And I have that because I have time at 0. I know that the A is the growth or decay factor. And I know with data that that is the y2 divided by the y1. So I have all the pieces that I need. So I write n equals starting number of 16, y ratio of 0.7118, exponent of t. Now, based on my experience of writing a previous NPAT formula, I am going to look if I need to adjust the time. And so I look at the time, and this is a +1, +1. And so I do not need to divide the time. This formula should work perfectly to model my data. So I'm going to go and create that. Let me sketch out what that graph is going to look like. So in the x direction is where I have time in hours. And my data goes up to 3, so I'll go up to 4 to give myself some room. In the y direction, my biggest y value is that first one at 16, so I'm going to go up to 20. This would be the milligrams. And I'm going to take that down to 0 in both the x and y direction, so I have the axis there. So let's go to our calculator. We'll go to Stat, Edit, arrow up to the list name, and hit Clear to remove data from a previous problem. And we'll put our time values in here, which are x values. They go in for our list 1. And we'll arrow over, and we'll put in our milligram values, which are our y values, as our list 2. Oh, I have a typo there. Let me go back. All right, so I have my data in. So next I'm going to set up my window. And we said we were going to go 0 to 4, just to give ourselves a little space in the x direction, and 0 to 20, again, giving ourselves a little space in the y direction. I'm going to go into my y equals. I see plot 1 is turned on, so I will see my data. And I want to type the equation that I wrote. So we had starting value of 16 times our y ratio of 0.7118. And then that was to the exponent where we use x in our calculator. And so we're going to hit graph, and we're hoping to see our points and our curve all together, and we do see that. Now, in our content guide, it told us to actually show our graph up through 8 hours so that we can see more of what's going on here. So I am going to change my window a little bit past the data by changing this y max up to 8. And so I'll look at my graph again, and I still see my data points, still see the curve through them, but by extending my window out a little bit bigger, it's more obvious that I have a concave up curve that is decreasing at a decreasing rate, which are some of the observations that we want to make in the future. So we're going to extend our time out here to 8 hours, and our value started here at 16. Beautiful concave up curve coming down and flattening out. And so we had our data points here at the beginning, and then we just had the continuation of that curve. So in our next video, what we're going to do is look back at these graphs and try to make some conclusions about the graphs, about the data, about how all that fits together into our MCAT formula.